Hello and welcome to the second lesson of Triple Science content for Miss Hawkins' class and Miss Evans' class. Today we're going to be getting more into the Triple Science content, and this is part of the Structure and Bonding topic 2, which is the triple only content of Structure and Bonding. We study the structure of atoms and bonds so we can understand and improve the properties of materials and chemicals. Last time we revised the patterns in the periodic table, electron configuration, group number, period number, and specifically group 1, group 7, and group 0. Today we're going to be concentrating on the transition metals, the central block of the periodic table. So today's driving question is, what is a transition metal? Properties, its ions, and its uses. Okay, here we go. Firstly, take a moment to think about what do all these have in common? And hopefully it is fairly obvious to you that they are all metals and they all have the properties of metals. Just to point out that calcium, we sometimes think of calcium as being part of milk, dairy, teeth, bones, but in that form we're talking about calcium ions. When calcium is an element, it is a metal in group 2, just below magnesium in the periodic table. So all of these are metals. What are the typical properties of metals? Well, here they are on the left. And what I'd like you to do is just pause the video and take a moment to come up with your own definition of these words. So you don't have to write it down, you can just think it or say it out loud and think about how many of these words you already know the meaning of, and just take a moment to think about that. Pause the video. Okay, we're going to take you through the meaning of these keywords. Right, here we go. High density means heavy for its size. Density means mass divided by volume, number of grams divided by centimeters cubed or liters. So how many grams per liter, how many grams per centimeter cubed, what is its mass per volume? Right, high melting point means it only melts at a high temperature. Metals have high melting points. Lustrous means shiny, and even the alkali metals are shiny. They don't look it on the outside, they look kind of grey and crusty, but when you cut them open, they are shiny on the inside. Alkali metals tarnish very quickly, but all metals can be made to be lustrous. Sometimes they need polishing, but they can be all made to be lustrous. Right, ductile means they can be formed into the shape of a wire. Malleable means they can be molded or shaped after heating. And high conductivity means a good conductor of both heat and electricity. So these are the typical properties excuse me, of metals. Right, now, not all metals are transition metals. Transition metals are found in the central block of the periodic table. So if we want to know if a metal is a transition metal, that's where we need to look. So let's have a look at the periodic table. On the left, we have reactive metals in group 1 and group 2, alkaline metals, and group 2 is sometimes called the alkaline earth metals, magnesium, calcium, reactive metals there. Then we have the central block in between group 2 and group 3. This block here, these are all called transition metals. They have the typical properties of metals. You'll have heard of some of them like iron, nickel, copper, zinc, silver, gold. Some of them you won't have heard of. Some of them are a bit more unfamiliar. Well, there are other metals here like aluminium and tin and lead. And then on the very right hand side of the periodic table, we have the non-metals. The noble gases are also non-metals. Just note that sometimes germanium and antimony can sometimes be classed as metals or non-metals. In fact, they are semi-metals. They share the properties of both. So different periodic tables label those two in different ways. But we're going to focus on the transition metals, the central block of the periodic table. And yeah, these radioactive metals like uranium and plutonium tend not to be included on the GCSE periodic table, but if you went on to study A-level, you would learn a bit more about that. Okay, here we go. You're going to need to refer to the periodic table. Out of this list, which are transition metals? Pause the video and decide which numbers are transition metals. Pause it now. Okay, here we go with the answers, hopefully nice and straightforward. It was number 1, copper, Cu there. Number 3, chromium, Cr. Number 4, palladium is Pd. Number 6, technetium is Tc. And number 8, osmium is Os. Right, moving on. So what is a transition metal? Pause the video and decide whether it is A, B, C, or D. Okay, here we go. The correct answer was A. An element found in the central block of the periodic table, and it has typical metal properties. So high density, high conductivity, ductile, malleable, high melting point, lustrous, and did I say ductile? Yeah, I did. Okay, right, let's carry on. Is there anything unusual about transition metals? If they're just like typical metals, like iron and zinc, is there anything unusual about them? Well, they all form coloured salts. A lot of paints and dyes get their colour from transition metal salts. And they are generally soluble as well, they can be dissolved in water. And so transition metals form a wide range of coloured salts, often used in paints and dyes. So we can see here cobalt forms blue and pink colours, CO there. Copper can form green and blue colours. Titanium tends to be white. And so they are useful as dyes and pigments. Right, now there is a naming rule for transition metals. You might see this sometimes, iron 2 sulfate. These are Roman numerals. So that's the Roman numerals, II means 2. And that refers to the iron 2 plus ion, right? It's always difficult to say that. The iron 2 plus ion has the name iron 2 in Roman numerals. Okay, sulfate is SO4 minus. And what tends to happen, this is a bit of kind of A-level chemistry coming in here now. When transition metal ions go into water, they attract water molecules, in this case 6 water molecules. And that salt will then have a characteristic colour. The water molecules can get trapped inside the salt, so you can evaporate the water from a solution, but some of the water will stay inside the crystals. It's called water of crystallization. Cobalt can attract ammonia molecules, right? And whether it's 3 plus or 2 plus actually changes the colour of the salt. So if you have a look here, cobalt 3 plus produces this orange salt, but cobalt 2 plus produces this purple salt. Now, what this goes to show is that firstly, metals always form positive ions by losing electrons. We saw that last time with the alkali metals like lithium. So they lose the electrons in their outer orbits to form a positive ion. Transition metals do something very similar. They always form positive ions, like iron can form iron 2 plus by losing 2 electrons. Right, but they have much more complicated electron configurations. Their electron structure doesn't always fit the 288 pattern. And we don't learn about that at GCSE, it's more of an A-level thing. But what we do learn at GCSE is the fact that a consequence of having a complicated electron structure is they don't always lose the same amount of electrons. Iron can sometimes lose 2 electrons to form Fe2+, but it can sometimes form Fe3+, by losing 3 electrons. So here copper 1, copper 1 plus, will have been formed by copper losing 1 electron. If copper were to lose 2 electrons, it forms copper 2 plus instead. So transition metals can form a range of positive ions depending on how many electrons they lose. Therefore, we need a way of naming the different versions, and we use Roman numerals to denote the charge on the positive ion. So if you see chromium 2, that means a chromium 2 plus ion. If you see chromium 3, that means a chromium 3 plus ion. Okay, right, so this version of iron was made when iron atoms lost 2 electrons to form 2 plus, and we name it iron 2 with Roman numerals. Here's another way of representing that with a half equation. Iron can react to form iron 2 plus, and it also forms 2 electrons when iron loses 2 electrons. Okay, but iron 3 plus is made when iron loses 3 electrons. No, hopefully you know this, or you might be doing this at the moment actually with Miss Hawkins in electrolysis. When we write a half equation, we don't write Fe minus 3 electrons. We always write electrons as a product on the right hand side. So if you see plus electrons on the right hand side, it does mean they've been lost from the left hand side. They've been produced as a product. So this equation actually does say that iron atoms have lost 3 electrons. But we don't write minus electrons, we show them being produced as a product. So really this says that iron can react to form Fe3 plus ions plus 3 electrons. Okay, can you define the naming rules for transition metal ions? Can you put it into words for yourself? What is the rule for naming the ion? Pause the video and say it out loud, or think it to yourself, or tell somebody if there's somebody in the room. You don't have to write it down right now because it will be part of the written task later. But can you put it into words for yourself, verbally or in your mind? What is the naming rule for transition metal ions? Pause the video now. Okay, here we go. I wrote that we use a Roman numeral to tell us the charge of the positive ion. So I means 1 plus, II means 2 plus. So for example, copper 1 oxide contains Cu plus. Cu plus is made when Cu loses 1 electron. Copper 2 oxide would contain Cu2 plus. This is made when copper loses 2 electrons. Now, I mentioned copper because that's quite a common example of a transition metal element which can form different compounds with different ions, and that affects the chemical formula. So there are two versions of copper oxide. Now this might look a little bit counterintuitive to begin with because copper 1 oxide forms Cu2O and copper 2 oxide forms CuO. I'm going to explain why that is. Copper 2 oxide contains Cu2 plus. We know that from the Roman numeral. The oxide ion is always O2 minus. Oxygen's in group 6, so it gains 2 electrons to form an ion, O2 minus. Now, a 2 plus ion has 2 positive charges. A 2 minus ion has 2 negative charges. So they attract in a 1-to-1 ratio. So Cu2 plus will attract to 1 O2 minus. Now, when that happens, they attract in a 1-to-1 ratio. We could write Cu1O1, but we tend not to write in ones. So the formula is just CuO. So when copper is a 2 plus ion, it attracts one lot of O2 minus to form CuO. So copper 2 oxide has the formula CuO. Let's have a look at copper 1 oxide. Copper 1, Roman numerals, refers to copper plus. Oxide is an O2 minus ion. It's always O2 minus. Right? But what that means is that this time copper only has one positive, whereas oxygen has 2 negatives. That means that this O2 minus ion will be able to attract a second copper 2 plus. Right? So actually 2 copper ions, copper 1 plus, sorry, O2 minus will be able to attract 2 lots of copper 1 plus. Okay, 2 pluses attract to 2 minuses. Now what that means is if O2 minus is attracting 2 lots of copper plus, then we need to write a 2 next to copper. So oxygen this time will attract 2 lots of copper because copper is only 1 plus, as shown by copper 1 oxide. Therefore, copper 1 oxide has the formula Cu2O. Okay, right. Can you put that into words for yourself? Say it out loud or think it to yourself, or tell somebody else if there's somebody in the room. Why can copper oxide have 2 compounds with 2 different chemical formula? Pause the video, come up with your own answer now. Right, so let's look at my answer. I said oxide contains the ion O2 minus. So in Cu2O, there are 2 Cu plus ions attracted to each oxide ion, hence the formula Cu2O. It will then have the name copper 1 oxide because the copper is 1 plus. In CuO, there is 1 copper 2 plus ion attracted to each O2 minus ion, and because it contains Cu2 plus, we give the name copper 2 oxide. Okay, right, something slightly easier. What are the uses of transition metals? Well, we've already seen they form coloured salts, which is useful in dyes and pigments. They can also be used in breathalyzers. There is a chromium compound in breathalyzers, potassium dichromate, that's called. Chromium is a transition metal because it changes colour when it reacts with alcohol. Let me just mute this, okay? If I might skip through this a little bit. So what they're going to do is put alcohol, ethanol, right, C2H5OH, and then they're adding potassium dichromate, which is orange, and a little bit of acid to speed up the reaction. And then when it's warmed, it changes to a green colour. And this is the basis of a breathalyzer. Test for alcohol is when potassium dichromate changes from orange to green. The reason why it changes is because the chromium ion is changing to a different version. Okay, but here we go. Here's a GCSE level question. Can you explain how chromium-2 would be formed from a chromium atom? How would chromium-3 be formed from a chromium atom? So don't worry about what I said about dichroma or color changes. Just concentrate on, imagine a chromium atom. How would it change into chromium-2? That same chromium atom, how could it change into chromium-3 instead? Come up with an answer. Pause the video now. Okay, here we go. My answer is as follows, that chromium-2 is made when a chromium atom loses 2 electrons. Hopefully, in your work on electrolysis with Ms. Hawkins, you'll become more familiar with half equations like this. And chromium-3, on the other hand, is made when chromium loses 3 electrons. So chromium loses 3 electrons, it forms chromium-3 plus chromium-3. Okay, any other uses apart from coloured dyes and pigments and testing for alcohol? Yes. Right, they make good catalysts. Manganese dioxide, manganese is a transition metal, and it is a really good catalyst for this reaction of hydrogen peroxide. This is sometimes something we demonstrate. I'm not sure if I've got a video of this or not. It's normally a slow process. You add manganese dioxide in there, and it speeds up the decomposition. You get a lot of steam coming out. Right, it's a good catalyst. A catalyst is a chemical which speeds up a reaction without being used itself. Oh, here we go. I've got a video. Let's have a quick look. Right, there's the manganese dioxide, transition metal in there, Mn. And look, with a catalyst in, the peroxide breaks down straight away, forming a mixture of steam and oxygen. Right, it wouldn't decompose like that if the transition metal wasn't present. So transition metals speed up reactions. They make good catalysts. Okay, right. Now, catalyst is a chemical which speeds up a reaction without being used itself. So why are transition metals useful? Pause the video, choose the correct answer. Is it A, B, C, or D? Pause it now. Right, the best answer on the screen there is D. They form a range of coloured salts and a range of positive ions, and they make good catalysts. Okay, into the writing task for this lesson. Driving question, what is a transition metal? We are describing facts and keywords for orange. We are explaining the main basic idea at green. We are explaining a situation in more detail using our understanding for yellow and combining in difficult ideas around chemical formula for blue. Here are some sentence starters. So pause the video and write out your work on paper or in an exercise book or in a Word document. Start with a driving question, then lay out your work, describe, explain, use, combine, and use the sentence starters. Make sure you are writing your notes in full detail, in full sentences. Pause the video, take as long as you need, 10 to 12 minutes, but this is where you need to put a good amount of detail into your work. Go for it, year 10. Okay, I'm about to move on to the video, so the answers in the video. Only look at the answers once you've actually done the work yourself. Really important to assess what you can do on your own, then use the answers to make any corrections you need to make and add anything in that you didn't quite get yourself first time around. Here we go. Orange, describe. The typical properties of transition metals are malleable, ductile, shiny or lustrous, good conductivity, high density, high melting points. You can use that as a list, as bullet points, but make sure you've used the sentence starter. They're found in the central block of the periodic table, so in between groups 2 and group 3. Explain why they're useful and what are the naming rules. They're useful because they are good catalysts and they form a range of coloured salts. The naming rules are, we use Roman numerals to show the charge on a positive ion. So ion 2 is a 2 plus ion. Ion 3 denotes a 3 plus ion. Yellow, using our understanding to explain the situation in more detail. Ion 2 is formed when ion atoms lose 2 electrons to make Fe2 plus. Ion 3, that should say, typo, is formed when iron loses 3 electrons to make Fe3+. Copper 1 is formed when copper loses 1 electron to make copper plus, and copper 2, that should say, another typo, is formed when copper loses 2 electrons to make Cu2+. Okay, then combining in the idea of chemical formula. Copper oxide has these two formula because oxide contains O2-. In Cu2O, there are 2 copper 1+ ions attracting. and because it's copper 1 plus ion, it's called copper 1 oxide. In CuO, the O2 minus only attracts one copper 2 plus ion. Because it's copper 2 plus, we give it the name copper 2 oxide. These other examples, less familiar, didn't explain this earlier to try and test you out to see if you could figure these ones out on your own. Right, CrCl2 and CrCl3. Chloride is always Cl minus. Chlorine's in group 7, it gains one electron to form Cl minus. In this chemical, there are two chlorides attracted to one chromium, so the chromium must be 2 plus. If it's 2 plus, we give it the name chromium 2 chloride. In this particular compound, CrCl3, there are 3 chlorides attracted to chromium, so chromium must be 3 plus. Therefore, we give it the name chromium 3 oxide. Final example, manganese. Well, oxide is always O2 minus. In MnO, the oxide is attracting one manganese, therefore it must be Mn2 plus. So Mn2 plus has the name manganese 2 oxide. In MnO2, if there are 2 oxide ions, that means that Mn must be 4 plus. Right? Mn4 plus gives the compound the name manganese 4 oxide. Although what we would look at A level is that it doesn't actually form a 4 plus ion because it's too difficult to lose 4 electrons. So instead we say it has an oxidation state of +4. That's something that we may come back to in a different lesson, and it's more of an A level thing really. That chemical has another name. We tend to call it manganese dioxide because there's 2 oxygens, a bit like carbon dioxide, manganese dioxide. But yeah, we say it's got an oxidation state of +4 because there must be 4 pluses to attract 2 O2 minuses, and we can write it as either manganese 4 oxide or call it manganese dioxide. Okay, what have you been able to achieve today? Could you state the typical properties of transition metals and describe where they're found on the periodic table? Could you explain why they're useful? Could you use your understanding to explain how positive ions are formed and why they are named in the way that they are? Could you combine together difficult ideas around the chemical formula of transition metal oxides and chlorides? Okay, write a sentence. Today I achieved something because I could. And please do share that with people at home. I say this all the time, but I think genuinely, it's really important to show people you've done your work so that they can be pleased with you. And hopefully, I hope you'll be really proud of yourself for getting a good level of understanding, whether you've been able to explain, understand, use, or combine. We really want you to aim high and use the answers to correct your work where needed so that you can get a full level of understanding of this triple science content. Okay, now you need to go back to show my homework and complete the 10-question quiz. Next time, we will be looking at the reactions of transition metals. Okay, thank you, Year 10. Well done. See you next time.